Okay, I'm going to go over the 6-question quiz that we had. And the very first question that we had on the quiz was x squared minus 6x plus 8. The first thing I want you to notice is that there is no number in front of the x squared. When there is no number in front of the x squared, it's always kind of understood to be 1. 1 times the positive 8 is positive 8, which means all we're doing is actually looking for the factors of positive 8. That's 1 times 8 and 2 times 4. Now, this sign right here is very important. It's the sign that you always give to the larger number in each set of factors. In other words, here is a set of factors in 1 and 8, and a set of factors 2 and 4. I'm going to give the bigger number in each set that negative sign. 8 is the bigger number, so it gets it. 4 is the bigger number, so it gets it. Now, the other thing I need to do to decide is whether or not the 1 and the 2 get a plus sign or a negative. The way I get that information is the knowledge that I need this to multiply to be positive 8. If I made this a positive 1, positive 1 times negative 8 would actually give me negative 8, not positive 8, which means these signs have to be both negative. Negative times a negative is, in fact, a positive. That's also true for this set. A negative times a negative is, in fact, a positive. Now, you can argue, but wait, I could have used 2 positives. That would still give me a positive 8. However, what you should notice is that 2 plus 4 is positive 6, not the negative 6 that we're actually hoping to get. That's the reason it's not 2 positives. So we are going with 2 negatives, okay? Because again, we want to make a positive. And whenever you see a positive, you can also kind of remember that this means the signs are going to be the same. So negative 2 and negative 4. Now, since there's no number in front, it means I can go straight to my parentheses with x. I've got negative 2 and negative 4. No number in front, nothing left to worry about, and I'm done. Okay. All right. Second question we had to worry about was x squared plus 5x minus 14. Again, you should notice there's no number in front of the x squared, which means once again, we're just taking that last number, negative 14. Again, we're looking for all of the pairs of numbers that when multiplied give me negative 14, and it's 1 and 14, 2 and 7. The next most important thing is what is the bigger number in each pair of factors. Bigger number in each pair is to get a plus. So 14 is the bigger number, it gets a plus. 7 is the bigger number, it gets a plus. This time we need to multiply to be a negative 14. So if I tried to make the signs the same this time, a positive times a positive is not a negative 14, so that won't work. I have to make the signs different. Positive times a negative is a negative now, okay? So in other words, when I see a negative sign over here, what I want to remember is that this means that they are different, okay? That negative says these signs are different. Now, I'm looking for a positive 5, and negative 2 plus 7 is, in fact, positive 5. Once again, there's no number in front of the x squared, so I can go straight to my set of parentheses. And it's x minus 2 and x plus 7. No number in front, and that means I'm done. Okay, question number 3 actually introduces that number in front. Whenever I have a number in front, I need to remember my formula, ax squared plus bx plus c. What we're looking to do is 1 over ax, and multiply a times c. So that first number times that last number, okay? A, in this case, is 2. C is negative 9. So 1 over ax, And then A times C is 2 times negative 9, which is negative 18. Okay, that's the extra step in this problem. From here, it's just a straight factor. Again, we're looking for all of the sets of numbers that multiply to 18. This number, once again, this sign is going to get to my larger pair of numbers. By now, we should be familiar that a negative sign means my signs are different. It means that I need my sets to have different signs so that when I multiply a negative times a positive, I do in fact get that negative number. So I'm going to give the other signs negative. And again, if you're ever not sure, check it. Negative 3 times positive 6, is that negative 18? In this case, yes it is, and that's how you're assured that you're correct. Now, this time we are looking for a positive 3. Negative 1 plus 18 is 17. That won't work. Negative 2 plus 9 is 7. That won't work. Negative 3 plus 6 is positive 3, which is exactly what I'm looking for. So that is the set that I am going to choose. Okay, the very last step in this question is I'm looking to see which parenthesis can be divided by 2, because that is what I started with, that 2 out front. You might give some thought to the first parenthesis with the 2x and the 3. I wouldn't pick it though, because 2 doesn't go into 3 evenly. The second parenthesis is 2x plus 6. 2 does go into 2 and 2 does go into 6. So that is going to be our best choice. So x plus 3 is what you get from that. And the other parenthesis just comes down with you. Always check at this point, is there any number I can pull out? Is there a GCF? There isn't, and so I'm done. Okay. The next problem was more of the same. Once again, a number in front. So same as before, 1 over a, ax, okay, because again, this is a. Here, c, multiply a times c, so 3 times 8, which is positive 24. Look for all of your factors of 24, 1 times 24, 2 times 12, 3 times 8, and 4 times 6. This sign right here, once again, is going to give to the larger number in each set. Now, again, I'm looking to see that these numbers multiply to give me a positive 24. I know one of them has to be a negative. However, the only way to multiply a negative and get a positive is by also multiplying a negative. A negative times a negative is in fact a positive. And again, you can use that sign as a reminder that my signs are the same. Okay. I'm looking for negative 14. Negative 2 minus 12 is the correct set, so that is what I'm going to go with. Negative 2 minus 12. I'm going to divide out the extra 3. Again, I'm picking this parenthesis specifically because 12 is divisible by 3 and 2 isn't. So the first parenthesis stays the same. On the second parenthesis, it becomes x minus 4. And I'm done. And again, check for a GCF. I don't see one in either parenthesis, so I can move on from here. Question number 5 is a binomial. Now, binomials have to be two things. The first thing that a binomial has to be are negative. Okay? It has to have that negative sign in the center. If it doesn't have a negative, it's not factorable. Okay? What I want you to notice about this one, let me switch to a highlighter, is that it is a positive. Everyone see that? Okay. This positive sign tells me that this binomial is not factorable. Okay? So the only answer to this problem is not factorable. Now, you might ask, well, why isn't it factorable? And that's simple. Remember before, we took our c, this is our c, and we're looking for factors of c, 1 and 9, in this case 3 and 3. To get a positive 9, I would have to have my numbers with the same sign. That would give me 10 and 6. Neither 10 nor 6 is in this problem, which means I can't factor it using the information that I've been given. Okay, and our very last question is yet another binomial. Before we said it's only factorable provided, 1, it has a negative. Okay, and this time you should see it does. The second thing you're looking for is whether or not it has perfect squares. Now, by now in class, we've actually talked about if there's no perfect squares, it normally means GCF. On this quiz, that wasn't a problem, but it will be on your test. So if there are no perfect squares, that means there's a GCF. Okay. However, in this case, 4 perfect square, 81 perfect square. Now you might ask yourself, what does a perfect square mean again? The answer is it means that when you do a factor tree for each number, in this case 1 and 4, 2 and 2, 81 is 1, 81, 3, 27, and then 9, 9. A perfect square is merely a number that can be written as 2 of the same numbers multiplied together. Okay, you should see 2 and 2, 9 and 9. 81 is a perfect square, it's 9 times 9. 4 is a perfect square, it's 2 times 2. Now, that's actually all that we need to know to solve the question. I can go straight into my parentheses. X squared is x and x, which means this is 2x, 2x. Sign is negative. That means I'm looking at different signs. Okay? And 9 and 9 from these perfect squares. Now you might say, well, how do I know this one's factorable? And that's simple. I want a negative 81, so I know my signs are different. 9 times 9 is 81. Negative 9 plus 9 is 0, which accounts for the fact of the matter that the middle term is missing. And that is what allows us to factor a binomial. And that is the entire quiz.